In section 2.3, we're going to be working with polynomial functions and their graphs. And here are your objectives for the lesson, all the things you need to be able to do by the time we finish. Okay, on this slide, don't get too wrapped up or worried about the fact that you see lots of letters here and a few numbers scattered about. Your goal when you take a look at polynomial functions, be able to figure out what the degree is, and then know what the leading coefficient is. For example, if I had f of x equals 3x to the third minus 2x squared plus 1, well, the degree is 3, and the leading coefficient happens to also be 3. Okay, polynomial functions of degree 2 or higher are going to have graphs that are smooth and continuous. Now, by smooth, we just mean there aren't any, sharp turns, say, like in an absolute value graph. And continuous, there just aren't any breaks. You could make the graph, with your pencil, never leaving the paper. Okay? So that's what we mean by smooth and continuous. Now, when we talk about end behavior, it just means what happens on the far left-hand side of the graph and what is happening on the far right-hand side. You may have places in the graph that are increasing or decreasing. The graph is going to eventually, rise or fall to infinity as it moves either to the left or to the right. So the sign of the leading coefficient and the degree are what you need to pay attention to when we talk about end behavior. Okay, and I've really already referred to what's on this next slide. As x increases or decreases, the graph of the polynomial function either rises or falls, and the sign of the leading coefficient and the degree of the polynomial will help us determine, does it rise, does it fall, what's happening on the left, what's happening on the right. Okay, so the leading coefficient test. First, you have to decide, is the degree of the polynomial even or odd? So if it's like a quadratic, that's to the second power, or a quartic, that's to the fourth power, those are even. And odds would be, say, cubics to the third power, those are odd. The other thing you have to look for is your leading coefficient. Okay, and whether that's positive or negative. So in the next slide, I sort of make a little chart that might be a little easier to memorize. I'm not so sure. We'll see. Okay, so to try to sum up what was on the last slide, and it's still in your notes, if the degree, n is the degree, if it's odd, but the leading coefficient is a positive number, then the graph is down on the left-hand side and up on the right-hand side. Now, if n is odd and the leading coefficient is a negative number, then the end behavior of the graph is up on the left-hand side and up on the right-hand side. However, if the degree is even, say it's a quadratic, or it's a quartic, or it's degree 6, that means n is even. If the leading coefficient is a positive number, then the graph is up on the left and it's down on the right. If it's an even degree function, but the leading coefficient is a negative number, then the graph is down on the left and down on the right. So here we are in example 1, where we're going to try to use the leading coefficient test on this function f of x equals x to the fourth minus 4x squared. The degree of the function, well, the largest exponent we have is 4. So the degree of the function is 4. Now, is that even or odd? Why, it's even. Now, even degree functions have graphs with the same behavior at each end. So now we have to just decide, is it up or is it down based on what the leading coefficient is. The leading coefficient, well, that's an understood 1. And this number is positive. So when n is even and the leading coefficient is positive, the graph rises, or it's up on the left. Over here, see, it's up. And it's also up on the right.